Hello there. My name is Denzel Dickson, and I am honored to present on proposing a system of neural networks to reinforce adolescent learning with the help of my mentor, Dr. Deborah Oyeyemi. Starting off with my presentation outline, I will first start with an introduction on this topic and why I care so much. Then I will elaborate on what learning deficits and neurodevelopmental disorders are and what seems to be the issue. Then I will propose an argument that neural networks are a solution to the issues listed, explaining their potential in improving the way adolescents learn. Lastly, I'll explain the limitations and overall summary and conclusion of this topic. So, starting off with the introduction, neurodevelopmental disorders and learning deficits, especially among adolescents, are very widespread, impacting millions. Oftentimes, these learning deficits faced by these adolescents come from not personalizing learning techniques to each adolescent's needs. These deficits can then pose multiple risks for the adolescent's future if not resolved appropriately. And now, more than ever, with the rise of technology furthering the gap in education disparities, we need dramatic modernized progress to tackle these challenges efficiently. And neural networks have shown to be the most optimal solution in dealing with these challenges. Firstly, let's define what neurodevelopmental disorders, also known as NDDs, are, and what learning deficits are, and what's the big idea. Key concepts to know as we go further into this include the posed detriments, costs, a need for accommodations, poor diagnosis as well as treatment, and a need for personalized learning. Neurodevelopmental disorders are conditions that impact brain development. In turn, they can impact personal development, social development, and academic development. Some common disorders you may have heard of include autism, ADHD, and specific learning disorders, or SLDs, which includes dyslexia. To properly accommodate adolescents with these disorders, the, there must be appropriate interventions. But the costs of these interventions are quite high, often due to the special education services and parental productivity laws. It is important to note that these services, time, and patience are necessities to properly accommodate them alongside many other interventions. Now, moving on to learning deficits, they are difficulties in learning information and skills. Some of the most common kinds are poor time management, procrastination, poor memory, and many more. And you most likely have gone through at least one of these in your lifetime of learning. They can show up in both adolescents with neurodevelopmental disorders and without neurodevelopmental disorders. And the key thing to note here is that learning deficits come from an inability to accommodate any learning needs the adolescent may have. These learning deficits pose many risks for the adolescent. They include, and do me a favor and take a look at the effects/detriment section. They include worsened conditions, mentally, academically, and sometimes physically. They also include poor academic achievement, dropping out, a limited range of options in career, as well as difficulties with independence. The causes for these learning deficits seem to stem from two main problems: poor diagnosis alongside treatment and a lack of personalized learning. In the poor diagnosis alongside treatment section, specific causes in this section include the biases specialists may have leading to misdiagnosis. As for parents, parental stigma on these disorders can impair both diagnosis and treatment. And as for teachers, because they often lack specialized training, they may handle situations poorly, leaving the adolescent at greater risk. In the lack of personalized learning section, specific causes in this section include a one size fits all approach to education. Since everyone learns differently, it is very inefficient in the long run when trying to educate adolescents in the most effective way possible. That is often due to a lack of needed resources like specialized teachers, effective technology, and many more. This highlights an urgent need for new ways to tackle these deficits, and a considerable solution has shown itself to be neural networks. Leading us to our next slide. What are neural networks and why are they a considerable solution? Here, I intend on proposing a system of neural networks and argue their potential in tackling these issues. Key concepts that will be covered here include unbiased independent decision making, automated decision optimization, types of neural networks diagnosing neurodevelopmental disorders, and simulations. Neural networks are models that analyze data and make decisions in the same way the human brain does. They're a subset of machine learning a branch of AI that analyzes data to make decisions. Do note, though, that the data they analyze is categorized, meaning humans have sorted out and organized that data for machine learning algorithms to then interpret. What makes neural networks special, though, is that they can make decisions without human intervention, and it is what makes them so key in supporting adolescents in their learning. Neural networks are made up of nodes, which are those dots you see in the first image. They are interconnected, forming layers, and these layers can be divided into three main sections: the input layer, where the information first enters the network; the hidden layer, where the information moves through to be processed; and the output layer, where the network's output is finalized, often being a prediction and or decision in our case. Neural networks can not only practically make decisions independently, but they also learn from their past mistakes just like humans. They adjust the way they will handle a situation based on past experiences and its relevance, exactly how humans learn from their mistakes, reducing error in their outputs. But this is how neural networks do it. They use an optimization process called gradient descent that adjusts the parameters networks use to make these decisions, also known as weights, until it finds the most efficient one. More specifically, an algorithm called backpropagation uses calculus to find the steepest drop in error, more professionally known as negative gradient. If that doesn't make sense to you, think of it like this. Imagine trying to find the deepest valley among hills. You find some pretty steep valleys, but you make sure to traverse all across the hills until you found the steepest valley downward. You then make sure to take note of all information about this specific position. This, in terms of neural networks, represents the greatest decrease in error. And the parameters at that position is what neural networks use to make their next decision. This is what makes the decision making process so efficient with them. Now we can take a look at the applications of these networks in handling issues related to adolescent learning. As a reminder, oops, um, sorry. As a reminder, the two main issues we faced in trying to support. Oh, sorry. All right. There are different types of these networks, and in these images, you can sort of see a little bit of behind the scenes and the logic behind the decisions. From feed forward networks, neural networks used for pattern recognition, to convolutional neural networks used for processing visual data, to recurrent neural networks used for processing sequential data. Now we can take a look at the applications of these neural networks in handling issues related to adolescent learning. As a reminder, the two main issues we face in trying to support adolescent learning were poor diagnosis alongside treatment slash accommodations, and a need for efficient personalized learning as shown in the green boxes. In tackling poor diagnosis, poor treatment, and poor accommodations, these two examples display the network's full potential. In our first example, a model developed by Stanford with the help of resources from Khan Academy and Google called Deep Knowledge Tracing Model, also known as DKT. It used recurrent neural networks to predict adolescent learning, specifically modeling their likelihood of getting the answer right. The model also personalized the learning paths to the adolescents based on that likelihood. In the second example, researchers developed models that diagnosed NDDs, such as ADHD and autism. In the research responsible for diagnosing autism, they identified autism with a 73.75% accuracy rate. Looking at the image on the far right bottom corner, you can we can get a good look at how the model for autism diagnosis is sorted, and sort of like how that data is received. In another model, in diagnosing ADHD, neural networks identified ADHD with a 99% accuracy. In tackling the need for efficient personalized learning, neural networks have also shown great potential as well. Personalized learning is important because, as stated before, we all learn differently, requiring different resources to learn most efficiently. One example of this being an algorithm called Duolingo's half-life regression, which basically simulated each user's ability to retain information over time, also known as the natural forgetting curve. As shown with the first image above, we can see a specific user's natural forgetting curve displayed over a 1 week and how steep that decline is. The algorithm then used this data to develop personalized learning schedules for that specific user, slowly reducing the rate of the user's forgetfulness. In the second image, note that the x's are the times when the user relearned information, and we see that over the month. The likelihood of forgetting decreased, became less and less steeper each time. Lastly, also by the way, this is one of my favorite examples. Researchers in Pennsylvania developed neuron simulation software, which modeled brain activity by simulating neuron communication and processes in the user's brain. They then developed a temporal convolutional neural network, which essentially predicted future neuron activity based on past data, showing immense potential for networks in predicting future brain net data based on previously recorded brain activity, pushing the limits of networks in reinforcing learning further. This in my proposed system, could ideally help networks get a deeper understanding in what they should be doing with their techniques to create a desired brain activity, that they are looking for in the adolescent. Now, lastly, for limitations, though neural networks have shown much potential, that it is still an emerging field with many limitations. For example, their black box nature means we can't see the quote unquote thought process of these networks, never knowing if any biases are being harbored. It raises major ethical concerns, especially in making big decisions like diagnosing disorders or personalizing learning pathways. Neural networks also require massive data to train on and specialized expertise in handling software and hardware of neural networks. Many schools lack the resources to do these things. It is important to also note that just like humans, networks don't know everything. No, not anything, everything, and relevant experience with the data that they're working with to some extent. Without that experience, if they're working with data that they don't sort of have experience with, they make much riskier, far-fetched predictions based on that little knowledge that they do have, also known as extrapolation, bringing up more ethical concerns. Lastly, with my conclusion with all of this, clearly, with all of these concerns, there's a long way to go before we can completely optimize the way adolescents learn, especially with an emerging mix of fields such as neural networks and adolescent learning. But it is important to keep going because our youth education is a priority. It is imperative that effective ways of educating us are promoted so that we are fit for the world during adulthood, because the youth is what defines our future. These are my references, and thank you very much.